We'll start this off with this basic question. Why use a remote auto tuner? I know most of you are aware of the fact that remote auto tuners exist, and many of you know a lot about tuners and so forth, and because they're very useful devices. I have more than I can count. They're stuck away here and there. But there are a lot of things people don't know about auto tuners because they're not quite familiar with the whole gambit here. So, antenna tuners have certainly been with us from the early days of radio. I don't know how many of you recognize this old warhorse. Wonderful piece of equipment, still a very useful device, the famous Johnson matchbox, which I believe had a true balanced output on it. I don't know how many people still run them, but they've certainly been around from the early days of radio. But tuners and auto tuners, there's still much of a mystery to many hams, even hams who've been around for a while, who think, well, I've used tuners all for years and years and years, I know all about them. Well, maybe not as much as you might think. And I don't mean to step on anybody's toes tonight with this presentation, but maybe you'll learn a few things that you didn't know. And some of this is for the newbie, some of this is for you who are experienced. So we'll cover both ends of the spectrum, because there are many misconceptions that persist about tuners. Okay, the reason number one that there are misconceptions about tuners, and I find this is a common reason, a piece of or lack of understanding, is there really, in broad sense, are two kinds of tuners, and that we're going to cover quite well here tonight. These two types of tuners, physically speaking, and they're also electrically different too, are tuners that you use in your shack and tuners that you use remotely or that you put out at the antenna. And some of you hams may be scratching your head when I use that term. Why in the heck would I want to put a tuner out at my antenna? Well, that's what we want to talk about here tonight, because there are plenty of good reasons why you should want to put them out there. And the reasons are growing as hams begin to use more and more what we call non-resonant antennas. Because characteristically or classically in recent years, hams have used mostly only resonant antennas. That is, you go to the store, you buy it, you bring it home, you hook up your SWR analyzer to it, and it shows you a 1-to-1 SWR. That's a resonant antenna. And with that, this is what in-shack tuners are basically for. But if you have an antenna that doesn't do that, and there are plenty of them, believe me, end-fed long wires and ZEPs and that sort of stuff, and several that I've been doing, like the Flagpole that I have been kicking around for a long time, no radio Flagpole, is a non-resonant antenna and needs a different kind of a tuner. All right, here's a tuner that many of you may have. Nice manual tuner made by MFJ VersaTuner. I've had one of these for years. Pretty good piece of equipment. You know, I can't give MFJ too great kudos for their construction, but basically pretty good stuff. And I have a lot of their stuff, as do many hams. And this is an in-shack tuner, as most of you, sits next to your rig, probably in your console or your ham table. But a lot of hams labor under the misconception, well, this is the only tuner I'll ever possibly need. It'll tune up anything. Oh, no, it won't. That's a big misconception. It will tune up almost anything, but you might not end up where you want to be when you've got it tuned up. That's the big issue between the tuner types. Here's another in-shack tuner that a lot of you may have, and these are good, of course. Here's a nice fancy rig, a Kenwood TS990, pretty big high-end sort of radio. And as you can see over there where the arrow is pointing, it's pointing at a little button, AT, auto tuner. And a lot of people think, oh, I don't need any more auto tuners. I've got this big rig and it's got a tuner in it. It'll tune up anything. Yes, it will tune up. It will give you a low SWR at your back of your rig, but it might not be doing what you want it to be doing. And that's what we want to talk about tonight. But a lot of hams think, oh, the only tuner I'll ever need, I've got it in that expensive radio I spent a lot of money for. Well, it'll do a lot of good things for you, but it's not the only tuner you'll ever need. Here's another type of in-shack tuner that a lot of hams have been buying these days. I have an LDG AT1000 Pro, which is a 1,000-watt auto tuner. I'm looking over at it right now in my ham console, which is about 10 feet away from me, and good auto tuner. It'll auto tune all sorts of things, but it's an in-shack tuner, as is this Palstar, very good in-shack HF auto tuner, full legal limit one. But there's another whole class of tuners, which you do need to be sure you really understand why there's another class and where you use them. These are tuners that you don't put in your shack, but that you put out at the antenna. And you need to know why you need to put a tuner at an antenna. That's quite an important principle, particularly if you're a newcomer and you hear this term tuner, antenna tuner. You go out and buy one. Why would you buy one that you'd want to put out there at the antenna? Don't you want it there where you can get your hands on it? A lot of people think that's the only way a tuner works. Not really. Well, anyway, here's the original, the one that probably first hit the market some years ago when SGC, who's still in business, by the way, and you can still buy this tuner, or it's often called a coupler as well. It's a remote auto tuner. This is a device designed to be placed out at the antenna, not to be placed in your shack. And it was probably the original that hit the market. I had one of these, pretty good auto tuner, remote auto tuner. And a lot of people think, I'll never need one of those. Only thing I'll ever need is that thing I got built into my rig. Oh, no, not so. Here's another little remote auto tuner that's been very popular over the years. I have one of these strapped to the back of the bed of my pickup truck, which is feeding a CB whip, and I use it to run HF whip with one of these ICOM AH4 auto tuners. Works quite well. It's again a remote auto tuner. It's not very far from me in the pickup truck, but it's out in the bed of the pickup truck, which is remote. You can still buy this one, a nice little remote auto tuner. And it'll handle 120 watts, which is probably more than most of you are running mobile. Most of us run 100 watts usually at most. And you can still buy this one for $299.99. Here's a remote auto tuner that MFJ sells. Now, I've used this one quite extensively. It's a pretty good remote auto tuner. It'll live out there, and you can see the brackets there to mount it to a mast or to a post out by your antenna. This one will handle 300 watts and has a reasonable price tag. Good design inside. The only kudos I won't give to MFJ for this tuner is that the box it's in needs a little better sealing. So if you happen to buy one of these, be sure you give it some sealant inside the gasket. Sometimes leaks in this tuner. So, but it functions quite well. But there is a reason why you might want to buy one of these remote auto tuners as opposed to that one you've got sitting beside your rig in your shack or built into your rig. There is a very good reason why. And that reason is, and this is basic radio to learn. Early hams knew this. Early hams understood this, but it's modern hams who have been so used to being able to go to the radio store and buy resonant antennas that they have lost sight of the fact that not all antennas are resonant. And that's the two categories of antennas. And that's why there are two categories of tuners. There are two of them, resonant antennas and non-resonant antennas. Some of you might think, how can there be a non-resonant antenna? Oh, yes, there can very easily. I'm going to show you the classic non-resonant antenna here in a moment, which some people think is a miracle antenna. Well, here are some resonant antennas. Let's understand what a resonant antenna is. Look at the lower left down there. That's an inverted V. Many of you have built inverted Vs. which you build with that classic formula, 468 divided by megahertz. And when you do that, you're building an antenna that's resonant, hence it can be hooked straight onto the feed line and will work quite well. In the middle is another resonant antenna. That's a spider beam, and you can see it has what looks like 1, 2, 3, 4, 5 different hexagonal, octagonal spider beam looking elements to make a multi-element beam. On the upper left, a nice big multi-element beam. These are all resonant antennas. And on the right is a vertical Hustler. I think that's a 5 BTV, or maybe it's some other number. I don't remember which one. But it's a resonant antenna. And why is it resonant? Why are all of these resonant? Are called resonant antennas? It's because at the frequency you want to operate them, they show a low SWR, as these sort of artificial curves on the Hustler antenna are showing you. On all those bands, 10 meters through 40 meters, the SWR at the operating frequency is low. In other words, they're resonant at that frequency. That's what defines a resonant antenna. It'll show you a low SWR at the frequency you want to operate it at. And any of these resonant antennas, you can just put energy in on those frequencies and it'll give you a low SWR. Basic definition of a resonant antenna. But now, here are some non-resonant antennas, which are becoming more popular as time goes by, particularly with the advent of non-resonant remote auto tuners. On the left, the military loves non-resonant antennas. There's a Humvee there on the left with a big whip antenna, and right beside it is the non-resonant auto tuner or auto coupler. It's an at the antenna non-resonant auto coupler at the antenna. Many of you may have done what I did in the past. I'm having a new roof put on, so I had to take it down. But many of you have gone up and put a loop around your house, like there in the middle. That's a non-resonant antenna. Very, very unlikely is it going to be the right length to tune up just naturally on any ham band. So it's a non-resonant antenna. That kind of an antenna needs a tuner at the antenna because it's a non-resonant antenna. Look at the one on the right. There's a fiberglass whip, one of those flagpoles, those fiberglass flagpoles, which you can readily buy. MFJ has a nice 32-footer, or you can get the windsock poles. And this particular ham is helixed to just a length of wire around that fiberglass pole. And at the base of it, though, you can see there's an AH4 auto tuner, a remote auto tuner. And that's a proper installation, as all of these installations are for non-resonant antennas. But notice, the non-resonant antenna needs the tuner at the antenna, not in the shack. And I'll explain to you why. And here are some typical non-resonant antennas that some of you may be using. ZEPs, Wyndhams, G5RVs, naturally non-resonant antennas. They may take some steps to make them resonant, but basically, fundamentally, they're non-resonant antennas. A long wire, just a random piece of long wire, is usually non-resonant. You can't hook it straight into your rig and have it work right. An off-center fed dipole. There's a common antenna being used today. I had a beautiful one up at my mountain cabin till I sold the cabin. Off-center fed dipole worked very, very well. But again, had to have a tuner at the antenna. Or a good example of a non-resonant antenna is if, let's say you've got a 40-meter or a 20-meter, a 40-meter antenna up, a dipole, an inverted V, and you want to operate it on a different band. You want to operate it on 20 meters or 15 meters. It'll probably work naturally for you. But you want to operate it on 10 or 12 or 17. On all those bands, it's a non-resonant antenna. And in that case, if you want to operate it right, you need to have the tuner at the antenna. So if you want to retune an antenna meant for one frequency to a different frequency, it no longer is a resonant antenna, it becomes a non-resonant antenna. And here's the classic non-resonant antenna. Some people think this is a miracle antenna. It's not. It doesn't. It's a good antenna. The 43-foot vertical. It has some nice characteristics on some bands, and not so nice on other bands. But it's fundamentally a non-resonant antenna, and I'm going to show you why. And here's a fellow hooking one up, and he's got a nice array of 43-foot verticals laid out there on the lawn. Now that's a good antenna, provided you put a tuner at the base. And don't try to tune this antenna up with a tuner in your shack. If you do, you're asking for trouble. Here's why that 43-foot vertical is a non-resonant antenna. Here's an SWR sweep, an easy neck sweep of it, frequency sweep, showing you the SWR all the way across the HF, all the HF band, the red line showing you the SWR with infinity at the top and 1-to-1 at the bottom. And so you can see that the 43-foot vertical, just without any kind of a tuner, for most frequencies, for most bands up there at the top, is a non-resonant antenna. You don't want to try to feed this antenna directly on those frequencies with your rig. It won't match it. It's only happened to be resonant at 3 frequencies, 5.5 megahertz, 17 megahertz, and in 10 meters. 10 meters is the only band in which a 43-foot vertical with 16 43-foot radials is a resonant antenna. The rest of the frequencies, the rest of the bands, it's a non-resonant antenna and needs a tuner at the base. Here's how I got into non-resonant antennas and tuners at the base. This is my little humble mobile home. And this is a off-center fed flagpole, which has been kicking around the bands for quite a while now. It's an off-center fed, half-wave, no radial, HF, non-resonant flagpole antenna. Doesn't need any radials. Why? It's because it's an electrical half-wave. It's not a quarter wave. It's not working a quarter wave against radials. It's a full half-wave electrical antenna. It's not fed at the bottom. It's fed part way up. You can see that top arrow. That's the feed point. And the bottom of this antenna is not connected to the ground or the radials. It's insulated. So there's 2 insulators in this antenna. By the way, it's a 20-foot flagpole, and it's made of 2-inch aluminum tubing. There was a commercial version out for a while, and the company didn't do very well with it. Not so much because it was a bad antenna, but it's because the owner was a little bit flaky. Anyway, so here's how I got into non-resonant antennas, this little flagpole. Another non-resonant antenna that I got into, and I was a big rag sailor for a long time, had a boat out of Marina del Rey in Los Angeles Harbor. And here's a fellow now, Joel Hellis, who was the technical editor for QST until he became a silent key in 2021. Knew him quite well, great guy. And he used to run a sailboat. And he used a non-resonant antenna, which, as a lot of rag sailers did, they load up the backstay of their mast. That's a metal wire going up the backstay to partly hold up the mast, put an egg insulator in the bottom, and load it up with an auto tuner at the base of the antenna. Excellent antenna for seagoing sailors. Interestingly, I've talked to the Pentagon Amateur Radio Club, K4AF. They have a non-resonant antenna. It's actually a marine antenna, a commercial marine antenna mounted up on top of the, I think you can see it in the far right, about in the middle back there, on the Pentagon. And they run it with a remote auto tuner mounted at the base. They use a marine antenna and a remote auto tuner or coupler for whatever they use it for. Probably spying, who knows. Here's a real typical use of a remote auto tuner. Here's a ocean-going fishing trawler, I think. And you can see it uses and you can buy this. This is the best known of the marine HF whips made by Shakespeare, the Shakespeare at 5300. You can see it mounted there on that vessel. The red arrows, and the green arrows are pointed to the coupler. The big one is the coupler at the base, or the auto tuner. They don't try to tune this up from inside the radio room. They tune it up right at the base, like you should tune up a non-resonant antenna. That's a 28-foot non-resonant fiberglass marine antenna, and it's grounded to a metal plate on the bottom of the ship. It can also be used, as you can see, with a wire antenna leading up to that pole in the front. These are two configurations on an ocean-going vessel. I thought, well, mostly the ocean-going boats didn't use HF anymore. Not true. Ocean-going vessels still use HF. In fact, I found this interesting, so I thought I'd show you just a little band chart here. This is an FYI band chart showing you that for ocean-going vessels, particularly ones that go into the proper blue water vessels, but even some around the coast use them, like Joel Hellis's sailboat, or mine, can use HF from your sailboat. On one of these marine bands, which are the black bands shown here, or the red bands, or the ham bands. And you can see they have just about as many bands for HF marine as we have for HF HFing. So you can easily see that auto tuners and non-resonant whips are very popular in the marine business, marine HF business. Okay, let's leave that away for a moment and go to the basic idea. How does an remote auto tuner work, which includes both remote auto tuners and the one you might have in your shack? Both work much the same way. It's a very common design. The remote auto tuner, or the auto tuner, was pretty much pioneered by this fellow, Dwayne Kincaid, WD8OYG, working for LDG tuners at the time. In fact, you can see LDG up on the board up there. He pioneered the auto tuner, which was a series of inductors. You can see them down the right, 8 of them in this case, and a series of capacitors. You can't really see them, but they're under the word capacitors there, which were silver mica capacitors, and 2 banks of relays, which switch those capacitors and those inductors in under the command of a little CPU, which was also on the board. So auto tuners always have a little CPU on them to control these relays, to switch in inductors and capacitors to do the matching. And it does it under the instruction of a little SWR bridge, which is also built into the remote auto, or the auto tuner, whether it be at a remote or one in your shack. So these are the basic components of an auto tuner. A 2 banks of reactances, in either inductances or capacitors, 2 banks of relays, one for each one of the reactances or inductors and capacitors, a CPU to do the switching, and an SWR bridge to measure the SWR. And so when you put this guy into tune, the CPU goes out, measures the SWR, and immediately begins switching all of those relays, and switches them all very fast. If any of you have an auto tuner, you know what it sounds like when it tunes. It goes as the relays do a lot of closing, and as the SWR is worked on, and it closes all of the relays until it finds the combination that has the lowest SWR. And with this series of inductors and capacitors, it can usually get the SWR down at least under 2 to 1 at least, which is perfectly good enough. And this was first featured in QST back in January 1996, the auto tuner. The basic idea of an auto tuner, remote or not. And your remote auto tuner works the same way. Now, to understand the auto tuner, though, we need to do a little investigation here on a Smith chart. Now, I don't intend to explain a Smith chart. If you know how to use it, then you know how to use it. If you don't, then it's too complicated to explain in 5 minutes. But fundamentally, just simply speaking, a Smith chart is a diagram of any combination of inductive or capacitive reactance and physical resistance that an antenna will have in it. Those are the three properties an antenna has: resistance, real resistance, in the two forms of it, two forms of resistance, and two forms of reactance, either inductive or capacitive. And it has to tune out those reactances so that the resistance will take effect. Okay, and but Philip Smith, when he did this brilliant work on this Smith chart, which was brilliant, he also noted in a simple sense that any part of the Smith chart, the whole array of reactances that any real object can throw at a transmitter, can be matched with a simple L match, an inductor and a capacitor set up in an L configuration, either a parallel in or a series in L match, and where the capacitor is the parallel or the inductor is the parallel, the capacitor is the series, or the inductor is the series. And you can see the four configurations of capacitor and an inductor, of which you can match anything, virtually anything on that Smith chart. I say virtually anything because some of the areas of the Smith chart are so extreme that you need such giant inductors or giant capacitors or tiny ones that you can't practically build them. But most of the whole Smith chart can be matched with 4 L matches, and that's what an auto tuner does. It seeks out one of these L matches to apply to your antenna, your non-resonant antenna. Philip Smith also noticed that the left-hand side of the Smith chart, called the low impedance side, because those are where all low impedances are on the Smith chart, can be matched with parallel in L matches, a parallel in L match. And the right side of the Smith chart can all be matched with series in L matches. The right half is the high impedance end of the chart. So in an auto tuner, there is another relay which chooses whether to go to the high side of the chart or the low side of the chart. In other words, to reverse the L match, to put the input element or the L and the C on the input or the output of the L match. And here you can see the circuit of an auto tuner. There are the inductors at the top. There are the capacitors at the bottom. And they hook out, and they can be hooked by those relays or connected to those relays via to the antenna via those relays. The capacitors can be switched in with the relays at the bottom. The inductors can be switched in with the inductors at the top. In one case, there's a shunt circuit, a shunt connection, and the top there's a series connection. In other words, you short out coils, or you short the capacitors to ground. And the additional one relay, which I've already mentioned, that one in the middle left there, that's a relay which changes which side of the L match the capacitor or the inductor goes, to make it a high impedance L match or a low impedance L match. Therefore, the microprocessor, because it has access to all of these relays, can pick a combination of L and C, whether series or parallel in and out, can pick a combination that'll give you a good SWR. And that's what it does when it sweeps through all of these with its clattering relays and finally finds the one that's best according to the SWR bridge. So let's understand now that we see basically how it works, the fundamental reason for all tuners. And this is pretty basic, but it's very, very important if you don't understand why you need both of these tuner types. All three of these elements, these are the elements of a ham station. You got a source of RF on the left, you've got an antenna on the right, a source and a load, and you've got a piece of transmission line in between. And what you want is all of these three devices to be 50 ohms. You want the transceiver to be a 50 ohm source. You want the load to look like 50 ohms. and you want the transmission line to be 50 ohm transmission line, or have a characteristic impedance of 50 ohms. And when you have these three situations properly fulfilled, you have a one-to-one match in the transmission line, and virtually all the power from the transceiver goes out into the antenna and makes radio waves. Now, as you see, all three of these have to be 50 ohms. A question I have, which I'll just answer in passing, which is interesting. A lot of people wonder, how can my radio be a 50 ohm device? Very simply, the way your radio is built, by Ohm's law, it always produces a ratio of voltage to current, which equals 50 ohms. So if it makes a certain amount of voltage out, it puts out the right amount of current, so E divided by I equals 50 ohms. That's how the radio, and that's what most radios are designed to do. Modern radios are designed to do today. They're built so that whatever comes out of the jack at the output of your radio is in the ratio of voltage to current, which equals 50 ohms. Presented to a 50 ohm transmission line, then hooked up to a resonant 50 ohm antenna, all the power will go into the antenna. Basic ham radio. All right. Now, let's get down to what's important here now in this whole presentation. Many hams labor under the misassumption that there are two ways to use a tuner. You can use it as you see it at the top, which is what some hams think is the only way you need to use a tuner. You have a transceiver, right next to it you have a tuner, and you have a piece of transmission line, open wire line or coax, and both of them have loss in them. And you have an antenna out at the other end. And this can work fine. But the other way to use a tuner is to put it at the antenna. We've already covered this, but these are the two basic ways. But some people believe that this is the upper one is the only way to use a tuner. And it is if your antenna is resonant. Then you can use a tuner in your shack. That's the only time you can use a tuner in your shack and not run into trouble. And if you do that, if you have a resonant antenna out there, you're going to have low loss in the coax, or if you have an auto tuner out at you'll have low loss in the coax. But put a non-resonant antenna out there, and now you're going to have high loss in the coax. So if you remember nothing else from this presentation, remember this. If you put a tuner in the shack and a non-resonant antenna out there fed with transmission line, you're going to suck up tremendous amount of power in the transmission line, and not a lot of it will get out to the antenna. That's a very basic principle. Put the tuner in the shack, try to feed a non-resonant antenna, and you're going to have high loss in the coax. A lot of people think tuners have a lot of loss. No, they don't. It's when they're trying to use them to feed a non-resonant antenna through a lot of coax or a lot of open wire line. That's when they have loss. It's not the tuner that has the loss, it's the transmission line that has it. In that case, if you've got a non-resonant antenna out there, you've got to have the tuner at the base. There just is no alternate to this. You might be stepping on some people's toes when I say this, but it's true. If you don't want to have high loss, don't try to feed your 43-foot vertical with a long run of coax. You're going to be doing nothing but heating up coax. Even the ARRL says this. An antenna tuner is not a good idea when using coaxial cable after it that has high SWR. The tuner might provide a 50 ohm match, oh yes it will, to the transmitter, but the high SWR in the coax will still exist between the antenna and the tuner. This translates into high loss in the coaxial cable. Very fundamental ham radio. If you didn't know this, learn it, scratch it on your memory. Let me show you this. Here's a 43-foot vertical, the so-called miracle antenna. It's not, it's just a good antenna, with 16 radials over average ground. And here's on the various bands. Here's the SWR. It'll show you if between the radio and that 43-foot vertical. At 3.5 to 1 or 3.5 megahertz, the SWR is over 100 to 1. At 5 megahertz, interestingly, it's okay, 2 to 1. 7 megahertz, it's 13 to 1. That's hardly good SWR. At 10 megahertz or 30 meters, it's 37 to 1. You can see the SWR of a 43-foot vertical, if you tried to hook it directly to your transceiver with coax, on most of the bands it would be useless. Only on 10 meters and on 60 meters, you might get away without putting a tuner out there at the antenna. Okay, here's my flagpole, my 20-foot off-center fed, no radial, half-wave flagpole that I showed you a picture of earlier. And here are some measurements I took with my VNA of it on the various frequencies, and showing you the actual impedances there in the middle. But on the right, notice the SWR. That's that 20-foot, 2-inch diameter flagpole with an insulator at the bottom and an insulator at 4 feet where it's off-center fed. 6 meters, it's 5 to 1. That's not too bad. But on 10 meters, it's 29 to 1, and so forth. Only around 14 megs was it any good. In fact, at 80 meters, it had 335 to 1 SWR. Hardly want to use that. You try to feed that directly with a piece of coax, nothing but hot coax. Let me prove something to you. Let's take 100 feet of RG58, common small diameter coax on 4 bands, 440, 2 meters, 10 meters, and 80 meters, and look at the loss in it. Look at the loss in it. In other words, the amount of power getting to the antenna. The scale on the bottom is 100% of the power getting the antenna and down to nothing on the left. And you can see that RG58, this is going to be 100 feet. I'm going to compare coaxes and things here for a few minutes. And if you take 100 feet of RG8, not a good idea to use 100 feet of RG8 anywhere, but if you did, you notice that on 440, you might not get out 10 or 5 watts if you tried to put it down RG58 on 2 meters. You're only going to get 20 watts out. Now, but also notice, this is at 1-to-1 SWR. This is if you're trying to feed a matched antenna, a properly tuned resonant antenna out there, one you took out of the box that has a 1-to-1 SWR. Even if it's 1-to-1, the loss is still pretty bad in the coax, RG58. By the way, these are the only figures you'll get if you look in the radio handbooks. This is not the only loss that can exist in coax. The only diagrams they put for loss in handbooks is the loss at 1-to-1 SWR. If the SWR is higher than that, the coax loss goes up terribly, as I'm going to now show you. Let's now take that RG58 and put an antenna out there that has a 10-to-1 SWR. Look what happened to the power. I'll just back up here for a second for you and show you. There it is at 1-to-1. There it is at 10-to-1. Look at how much power you lost simply because the SWR of the antenna was 10-to-1. Let's now take 100 feet of RG8 at 100-to-1 SWR, which is, as you could have seen on various bands, you can easily get 100-to-1 SWR for a non-resonant antenna. That 43-foot flagpole has 100-to-1 SWR, 43-foot vertical has 100-to-1 SWR on a couple of the bands. So you try to feed it with 100 feet of RG58, and you're going to get everything less than 20 watts out with 100 watts in. All right, you'll say, okay, I'll use better coax. Okay, I'll get the good stuff. I'll get LMR 400. That's really good coax. There's no loss in LMR 400. Oh, yes, there is. Here's 100 feet of LMR 400 at its best, 1-to-1 SWR. You're feeding a resonant antenna. You've got a nice commercial antenna out there, or you built yourself an inverted V and you matched it properly to 1-to-1 SWR. cut it to the correct length and so forth, and you feed it with 100 feet of LMR 400, 1-to-1 SWR. You could look this up in the handbook. This is where I got these figures. As you can see, on 80 meters, almost all the power gets out, and even on 10 meters, nearly 90 watts gets out, and even on 2 meters, 70 watts gets out. And look at 440, you're still getting half the power out. But this is high loss. This is good low loss coax. This is one of the better coaxes you can buy. So you'll say, okay, I get the picture here. Coax can eat power. I'll beat it. I'll trick it. I'll use open wire line. Open wire line has no loss. Not so. Oh, by the way, here's LMR 400 with a 10-to-1 SWR. Here's LMR 400 with a 100-to-1 SWR. Still not getting over 30 watts out on 80 meters, trying to feed that 43-foot vertical. Okay, but you'll say, I'm going to beat it because I'm going to use open wire line. Here's 100 feet of 450 ohm slotted window line. Good transmission line. Good stuff. I use it for a lot of things. And it does work very well. But notice, even open wire transmission line has loss. Notice on 70 centimeters or 440, 100 feet of it, you're only getting about 55 watts out for 100 watts in. It isn't as good as you might think it is. You know, this might blow up a few myths. This is why commercial stations that run open wire line run 600 ohm line or even higher than that. I remember visiting Radio Luxembourg over in Europe, where their lines out to their low LF transmitter were ceramic insulators spaced 2 feet apart to keep the loss down. So even LMR, even 450 ohm ladder line has, even at 1-to-1 SWR, which is the best it can do, still has some significant loss. But let's look at it if we raise the SWR. 10-to-1. It went up some, not as bad as the coax did, certainly not as bad as RG58 did, but it went up some. Now on 100 feet on 70 centimeters, you're only getting 85 watts out. That's okay. Then probably if that's what you're feeding it, feeding a 440 antenna with 100 feet of 450 ohm ladder line, that's very acceptable. But there's still loss, as you'll notice it. But let's raise the SWR some more. About 100-to-1 SWR with 450 ohm ladder line. As we've seen, a non-resonant antenna, a 43-foot vertical out there, my non-resonant flagpole can easily throw 100-to-1 SWR at it. Look at what happens when that happens. You're not getting nearly as much power out as you think. So the conclusion to this story is, and I hope I've not stepped on anybody's feet here, but for non-resonant antennas, your ZEPs, your long wires, your Carolina Windhams, your G5RV on other bands, trying to reload your beam on some band it wasn't made to operate on. The tuning must be at the antenna, not in the shack, if you really want to get the power out there. A sidebar, as for the last slide here, the last thing we're going to talk about. Some hams think, I don't like antenna tuners, they're very lossy. Oh, no, they're not. Here's a comment from the QRZ forum, but you'll find this from any good antenna designer. You know, Jerry Sevick or Lou McCoy used to echo this all the time. W2DU. I used to say this again and again and again, and yet many hams still think that antenna tuners are lossy. No, antenna tuners are not lossy, particularly if they're built with good, large, high-Q inductors and capacitors. Because here's a rule of ham radio. This is another one to learn, to memorize. Inductive reactance, in other words, the property of a coil, the tuning property of a coil. Capacitive reactance, the tuning property of a capacitor, does not consume power. It only transforms power. Only the slight losses that there might be in these elements. If your capacitor has a little dissipation, if your inductor has some resistance in the coil. But generally speaking, the inductors and the coils in an antenna tuner don't have high losses. And antenna tuners are not lossy devices. Why do hams think it? Because they're trying to use coax after the tuner feeding a non-resonant antenna or a resonant antenna on a band that it wasn't meant to work on. So coil and capacitors are reactances. They have no losses. So a closing example. Here's an antenna that I've become fairly well known for. This is called a double inverted non-resonant HF delta in skeleton slot antenna. Here it is in my backyard. I took it down recently because the pigeons thought it was a great roosting nest, and my wife objected to the fact, and I did too, that the pigeons did you know what when they sat on top of the antenna. So I took it down. Anyway, I went to build another antenna with the mast anyway. But this is a great little antenna, 25 foot high here, excellent performance on all HF bands. Notice the blue box at the bottom. That's where the tuner is. By the way, it didn't have an auto tuner. I used it with an auto tuner, but I also began using it with a manual tuner. And this was the manual tuner. I built myself a little homebrew L match with a roller inductor and a tuning capacitor. And I put some marks on the base after I tuned it up on every band. All I had to do was step outside, turn the knobs, and it was tuned up on the band I wanted, went back in the house and operated it just fine. So you don't have to spend the money on an expensive auto tuner. You can build one much cheaper here. I think I spent about $25 to build that little variable L match. And there's a banana plugs there at the back, so I can switch it from the L in or the L in series or parallel, as Philip Smith pointed out with the L matches. It's a good way to, you're on a non-resonant antenna, and you can see the wires going up to it. By the way, if any of you are interested in that little antenna, it's all talked about in detail in my Kindle ebook, if you've not availed yourself of one and would like to. Slot antennas for ham radio, showing a picture of the best known slot, the TV dish made as a 2-meter antenna, which my neighbors had no idea that it's a 2-meter antenna. Efficient slot antenna cut into the back plane of a TV dish. You can get it from that QR code if you want to, or just go to Amazon.com and search for slot antennas for ham radio, the forgotten antenna. It's a Kindle book. It's $4.95 if you want to buy one of them. And that's it, folks. Here's my little doggy. No, she does not have a German call sign. I just like to pretend she does. D0GGY. You want to get a hold of me? I'm here most any day, particularly in the mornings. There's my QR code or my email address there. You can reach me there anytime. Or if you want me to give another talk to your club, you can find all the topics at W6NBC.com. And that's it.
All righty, John. Hey, thank you. Jeff put out the link a little bit ago for the drawing, so DRC members are eligible. So if you care to join in on it, you're welcome to. Go to the link, and it should still be there, Alex. Is it not? It should. It's still there. The second one from the top in the chat. So there you go. Anyway, any questions for? Yeah, Jeff says you click it, get on the link, click the link. Any questions for John? One at a time. Go ahead. No. Bill Worthington.
He's muted. Muted.
You're muted, I guess, Bill.
Not anymore.
Okay, well.
Now you are.
Talk away.
Okay. One thing I've gotten from this, and I may have read it somewhere else, but should you keep your transmission cables, whether they be coax or anything else, as short as possible?
Why, of course.
Okay.
That's sort of fundamental ham radio. The more you have loss. But with good cable, And low, if you keep the SWR low at the other end, the losses are very reasonable. Just don't use little diameter cable, you know, RG58 or Mini 8, and feed it way back out to the outer 40. You're going to eat up all the power in the cable.
Yeah. The thing is I just guesstimate how much cable I need and buy that from HRO. And I don't know if I think they have a way you can special order a cable length, but I'm not sure.
Well, I think you can buy it from. There's certainly companies that'll make up coil coax pieces with coax on the end of it. I happen to have the crimping tools to do it with, so I make up my own cable. And I like LMR 400. It's a bit stiff and difficult to bend, but although they make a flexi version. RG213, which is basically RG8, good cable too. But I wouldn't make a run over. I wouldn't make a run over about 25 to 50 feet in anything but RG8 or LMR 400. Even on HF, the losses are pretty significant.
Okay, thank you.
Question, John.
Sure.
Here in Colorado, the Denver area, Mile High City, we're upwards of 6,000 feet elevation.
Snow and ice.
Yeah, but in the summer, well, even in the winter, we get massive ultraviolet here.
Yeah.
And so you put up LMR 400, tape it up the tower or across the roof or something like that. How long do you think that cable should be up there before you check it or replace it?
Well, I don't have hard figures in this, but I know the polyethylene jacket, which is what LMR 400 has, is pretty tough. Polyethylene is a pretty UV insensitive plastic, and that's what largely eats up your coax. Is the UV light in it. If you're worried about it, you can always buy yourself some half-inch PVC pipe from the hardware store. Put the coax inside of it. That's a good way to protect it. But LMR 400 will last a long time outside or even buried.
Okay, thank you.
We see Jim Blanchard raised his hand there. Jim, unmute and ask your question.
John, thanks for the presentation. Question: is there an advantage to using both tuners, one at your rig and then also at the antenna? Is there an advantage to that or disadvantage?
You mean to use a tuner at both ends?
Right.
Oh no, that's perfectly acceptable. You can have as many tuners in line as you want. Because tuners are essentially, as I mentioned, largely lossless devices. So that's what I do with that little manual tuner I showed you that I had out at the antenna, just the rotary inductor and so forth that I had under the Rubbermaid tub. That's what I do. I just walk out the door, walk about 100 feet back to the antenna, turn the little dials on my little manual tuner, little manual L match out there, and put it on the band marks that I made on it earlier. Then I go back in my shack. Then I can use the auto tuner in my rig, or the outboard auto tuner that I have in my shack to touch it up. Perfectly okay to touch up another antenna tuner with another one down the line.
Yeah. Okay, great. Thank you.
Okay, any other, let's see, Brian Carney, go ahead.
You're muted, Brian.
You're still muted, Brian.
Yeah.
Yeah, Brian, you're still muted there, bud.
Okay, I got it figured out. You click a different icon. You could probably always paint your coax to keep the UV from getting to it. But my question is, you said that the military loves non-resonant antennas. Why is that?
Because they cover such a wide range of frequencies on HF.
Oh,
And,
that makes sense.
And So generally speaking, and of course they're using it largely out mobile, or I guess they're using it from command stations as well. Yeah, it's because of the large number of military frequencies they have available to themselves. The auto tuner just makes it easy, and because most of the people that are running the radios haven't the foggiest idea how a radio works.
Okay, you good with that, Brian? I'll assume
Sure.
so.
I guess I got one more. I heard someone talking about tuners once, and you talked about the opposite side of the Smith chart. There's people that say you can put yourself on the other side of the chart by using a quarter wavelengths of extra coax.
That is absolutely correct. One of the elements that you can often use to do matching with are lengths, are what we call stubs of transmission line. If you look on a Smith chart, and I could demonstrate this, but if you look on a Smith chart and you have some impedance you want to get from somewhere on the Smith chart, you want to get it over to the middle where 50 ohms is. If you put transmission line either in series or parallel, it rotates around the Smith chart in a circle. So if you're over on the right at the low impedance, or high impedance end, or low impedance, which I forget which one is which, and if you put a piece of transmission line, you can rotate right around to the low impedance end with a piece of coax. So coax is because remember, what is coax if it isn't a resonant length? If you don't have a quarter wavelength or a half length piece of coax, what is it? It's an inductor or a capacitor. It's either inductive or capacitive. So it acts just like the coils or the capacitors in a tuner. So you can certainly use coax to, an example might be this. And have you ever built magnetic loop antennas? Well, if you build a magnetic loop antenna, you can make up that big capacitor that's up at the top of it. You can make part of it up by putting a stub of coax down hooked to the feed point.
Wow, that's interesting. Yeah, I've been thinking about building a magnetic loop, so maybe the vacuum variable could be smaller value.
Yeah, I'm doing an article and a design right now for a 4-foot magnetic loop, all made with aluminum foil tape and some aluminum foil flex conduit, and it uses a tuning capacitor. Doesn't use any expensive tuning capacitors, just uses a sliding piece of PVC inside of the one pipe with some aluminum foil on it to form a capacitor as it passes over and get rid of all those expensive rotary capacitors or vacuum variables, which cost a fortune.
Thank you much, John.
Okay, last call to get your name in on the drawing, if you haven't already. And any other questions for John?
Well, as I say, I'm available any day Pacific time, 9 to noon, pretty much, and you can generally get me by email, which again is W6NBC mail@gmail.com. You can send me an email. I'll be glad to talk to you, or we can set up a private Zoom session and chat away.
Okay, real good. I see Forrest got a question, I believe. Go ahead.
Yes, to follow up on Brian's question, if you put an auto tuner at the base of the antenna and use a manual tuner inside the shack, that would be okay?
Perfectly okay. It's what I do all the time, except I don't use an auto tuner out there. I just use a little manual, which I get it in the ballpark with. So the basic way to use a pair of tuners, one out there and one in your shack, is to use the one out there as a sort of a pre-tuner. Don't try to get that one out there down to 1.111111 to 1, just get it down under 3 to 1 so that you get the loss in the coax down. That's the reason why you need the tuning out there, is to keep the loss in the coax from being terrible. And all you need to do to do that is to get the SWR out there down under 3 to 1. Then you can fine tweak it in your shack with your tuner in there, manual or automatic.
Oh, thank you. I have one other question.
Forrest, you got some background. Somebody does. There's something talking.
Okay, it was my wife watching TV.
That's okay.
Anyway, so the power output, because I want to put a amplifier on my HF. What's going around it? Well, it's a 922 Kenwood 922, which is roughly 1200 watts. Do they have the auto tuner that would fit, that would handle that capacity or that power?
There's no 1,000-watt or full gallon remote auto tuner on the market. There's a 600-watter, the LDG, which is the one I use. I have one. The LDG RT600, which is still available, in fact, it's the remote auto tuner I recommend, but they're about $400. And it's an excellent, you just have to throttle your amplifier back a little bit when you use it, that's all. But you can, in other words, if you're putting a full gallon auto tuner in your shack, and if you're trying to run a full gallon in your shack, you want to keep the drive back so that you're not putting out more than 600 watts into that RT600. Although the 993 BRT MFJ tuner, which is a 300-watter, is certainly a good bit of power. That's only 1 S point down, roughly, over a full gallon. So you can, there certainly are high-powered tuners you can use.
What mode would you operate with it for us?
What was that?
What mode would you operate with it? SSB, CW?
SSB.
Yeah, so your PEP, your peak envelope power is not going to be a full gallon.
Yeah, SSB, the average power out is much lower. So if you're going to go key down CW or one of those modes, then you're going to have to, and you're going to try to put a full gallon out. Then you're going to need a full gallon tuner. But with a less power tuner out there or in your shack, you can get by on SSB or with less.
Well, the CW, that was my New Year's resolution for the last 3 years, is to learn CW. So, and I just renewed it. I'm going to try and learn CW this year. But anyway, thanks for your information. Very good presentation. Learned a lot. And thank you again.
Glad it is. And again, if you want me back, I've got several other talks. Just go to W6NBC.com and we got several other things.
I'm sure.
And Forrest, you probably don't need 1,000 watts on CW unless you're going to talk to Mars.
Yeah, right. FT8, 1,000 watts on an FT8.
There you go.
That's true. That's true.